All right, welcome this evening. Welcome to our third session on project management, the Diploma of Project Management. Everybody says we're loud and clear, so that's great. What we will be doing tonight is managing time, and there are 6 processes in this one. So I think that's what we will start with this evening. Kim, I will deal with your question that you emailed to me during the question and answers, and then I'll just write and return your email to you tomorrow. So, welcome everyone. Right. If we look at our fridge magnets, we have 5 process groups, if you remember, and I'll take you through those just now. And in those 5 process groups, we have 44 processes. And 6 of them we're going to do tonight. 6 of them we're going to look at in the area of, and the knowledge area, and there are 9 knowledge areas. And in those 9 knowledge areas, we are doing project time. So we're going to look at 6 of those processes and how they work within the process group. So that's what we're going to be doing tonight. Managing time for the project. This is a fishbowl view of time management from the first one that we're going to be looking at tonight is the activity definition. How do we define activities? So this has all got to do with each little activity. Do you remember last week when we did project scope, we did a work breakdown study, a work breakdown structure, and we got to break it down to that activity. And what we're going to be doing tonight is looking at those activities. So the other thing that's interesting, you notice how many parts of these were planning. At least 4 of these processes are in planning, in the planning process group, and 2 of them are in monitoring and control, or executing and controlling. So that's where we are this evening. That's what you're looking at, and the first one we're going to look at tonight is activity definition. All right, if we have a look at this, if we wanted to define the activities, how are we going to define them? Well, there's a number of inputs into this process. Does anybody remember what process assets are? Organizational process assets, or environmental, or enterprise environmental factors. Anybody remember what that is? I know we bring it up time and time again, but that's what it is in the project. So this is terminology that is used in the PMBOK. Procedures for doing things, yes, that's the organizational process assets. And we actually put it back into that organizational process assets. The environmental factors are all those factors that affect the enterprise. Okay, all the things that affect the enterprise. And then we're going to also put into here our scope baseline. Now, where do we get our scope baseline from? Anybody has from our scope management plan? That's actually what we're getting. And remember, we talked about a baseline. Our scope baseline. This is what the baseline is. And now we're going to look at all the activities. What will come out of this process, at least, is a list of activities. All right, we want an activity list of this process. So if we're going to define all the activities, we want a list of all the activities. And we want the attributes of those activities. In other words, what is the character? What is this activity about? Give us the attributes of it. That's what we want from that. And then we want a milestone list. Now, what's the difference between an activity and a milestone? Can anybody hazard a guess and give me an idea of what a milestone is and the difference between a milestone and an activity? Oh, come on, help me out here. Please. Milestone would be some major achievement. Yes. All right. That's a good characteristic. It's some major achievement. But there will be one significant attribute. Track small steps. Yes. Well, you see, now this is Graham. This is why I asked the question. Graham says just tasks, just small steps. Come on, help me out a little bit more. You're on the right track, Colin, but you haven't given me a good answer yet. Come on. What's the one attribute a milestone doesn't have that an activity would have? Zero time left. Yes, there is nothing that's going on in a milestone. A milestone has zero time length. A milestone is something that we get to and we say, hey, we've achieved this. So there's no work. There's no work. Yeah, thanks. You're right, Colin. Phew. There is no work in this. Right? So a milestone and the list of the milestones are those breaks that actually show us that we've achieved something, but it has no work attached to it. Right? So we must see it from that perspective. All right, the next thing is, if we had to do something, we'd have to create a work breakdown structure. Now we should have had it if we've done our work correctly in the scoping. We should have a work breakdown structure of some sort. And within that work breakdown structure, we're going to be using some of the following things in defining our activities. All right, and the most important thing in this one is the work breakdown structure dictionary. Remember what all that is? That's where we actually start defining these. So now we're going to refine these. Right, we're going to refine everything that's in that in that dictionary. We're going to use the scope baseline as part of that. So we're going to probably modify and put in more detail in our work breakdown structure. We're probably going to have more at this stage of the project. Probably going to have more detail in our work breakdown structure. So I told you we're going to go through iterative processes. So although in our scoping activities we're going to create a work breakdown structure, in this stage we are going to refine that even more. So that decomposition, that's what we do when we call a breakdown structure. The word that we would actually use there would be decomposition. All right. Deborah would probably be very familiar with that term because we use that when we break down processes and we're defining processes and objects when we define programs, right? When we're defining and analyzing a business process, we call it we create a decomposition diagram which tries to break down the work into smaller pieces. So that's what a decomposition is. We do the same thing in project management. We do a decomposition. Another tool that we actually have, and I'll get into the tools now. Another tool that we have here is what we would call a rolling. Whoops, lost myself. Is what we might call a rolling wave planning. Now, I've used this a couple of times, and that is because it's sometimes difficult to actually get all those activities in the first part. Where if we planned everything up front, we sometimes can't go into the detail enough because we don't know what's going to happen in the future. Right? You read a little bit about it a while back. Yes. This comes up very much. If you've been keeping up to date with any of the project management things, you've probably heard about agile projects. Agile projects. And agile projects, one of the techniques that they actually use is this rolling wave. It reminds me of the last development that we actually did. We actually did it exactly like that. We planned very roughly the whole outline of what the what the development would be, and then we took a small part of it and we planned that in detail, and we gave that one. So we prototyped the whole thing in general, and then we kept on doing an iterative process. And one of them, we had at least 3 iterations on them, and we got down to more and more detail in that. So in the project for doing that, what we actually did is that we didn't define the detail of the activities in the phase. So we had 3 phases within that one, and we only defined each phase as we got to that phase. So that's often how projects are done, and a rolling wave is often a good way to do a lot of projects. It gives us a lot of flexibility, but it also has a risk attached to that. Right? Anybody can hazard a guess at what the risk is? What would the risk be of a rolling wave? It's a good one. Probably not enough planning, but it has a problem and the risk of scope creep. All right. Remember, you can actually now expand your activities, and suddenly you've got too much here. So it's not so much planning as it is scope creep. In other words, you can start putting things in there that the stakeholders start having an influence on this one, and they want this a little bit more. And quite right, the other one is obviously one of the risks would be that you might not have planned for some eventualities as well. So there are some issues with that one. All right, the other tools and templates that we would be using here would be templates and obviously expert judgment. Now, that's what we've done in the first one. All right, so defining activities. That's we will come out, if I just go back a little bit, we will come out with an activity attributes, we will come out with a milestone list, and we'll come out with those activity lists. So what's the next thing that happens in project management? Is defining the sequencing. Defining the sequencing. What do you think we mean by sequencing? All right, now this one, it's very easy to see these in sequencing in construction projects, okay? Because there are certain things that have to happen. You cannot build the roof before you build the walls. You can't build the walls before you've done the foundation. You can't do the foundations unless you've leveled the place. So there's certain things that have to happen in certain places, right? So sequencing is another very, very important part of planning. It's a very important part of putting your project together, is to do that sequencing. All right, so what do we have? What is the process to get that sequencing? Well, if you have a project management tool like Microsoft Project, what you would probably do is go into the data entry part of it and write down all the tasks that you think. You'd take your project team, you'd brainstorm it and break it down some more. At that stage, you wouldn't have tried to sequence these things. You'd try to just get them all down. It would probably end up in some kind of sequence, but you really are going to do that after you know what all your activities are going to be. So you're going to take your milestone lists, you're going to take your activity attributes, you're going to take your scope baseline, because your scope baseline is going to tell you in broad sequences what should be happening. And then you're going to take all those processes, and we're going to come out at the end with it with a project schedule or a network diagram. Now this is what we're going to talk about tonight in a little bit more detail on some of the network diagrams. All right, and we'll see that we'll get right to the end of this. And network diagram is probably a very good part to actually see your project from a perspective of planning and the impact of various activities on one another. So that's what's important about this part of the planning. And in the old days, before we had Microsoft Project, in the older days, before Microsoft Project, this what they called arrow diagramming method was very much used. All right, what they would have, do you see that what we would have in this one, if we had to look at a network and we were building a network, we'd have a start, right? It's got a little node there, and there's a start, and then there's activities A, B, C, D, E, F, And if you can remember those questions that we had in this timing, if you've done them, I think most of you've done them. You had one that said, okay, which one would end up, which one would finish long, which one would take longer, which one would be the critical path. If you can remember that question. Now, the activity would be defined in the arrow. Okay, that's why it's called arrow diagramming. Right. So what we're trying to do here is identify the arrow. The arrow says what is dependent on what. So if we look, B and E are dependent on two activities. All right. B is dependent on A as an activity, and E is dependent on D as an activity. In other words, you can't start E until D is done, and you can't start B until A is done. Not only that, you can't really start C until D is done, or B is done, or A is done. Does that make sense what I'm saying? All right? If I'm not making sense right now, please just put up your hand. So if I don't see any hands, then you understand what I'm trying to say here. Now, in one of your questions, and I'm just saying this one because it's one of the, I think, a trick question in the PMI test. We won't probably do that when we do the diploma because we don't do tricky questions like this. But they have a tricky question here, and they say, which method has dummy tasks? Right, and this is the one that it is. All right, because the only way that you can actually show a dependency on this diagramming is with a dummy task. All right, does that make sense? Yeah. Okay, so you'll see the dotted line there. All right, it has a dummy task. Now, we do have another one that yes. Okay, Colin, do you want to? I'm going to give you the microphone. Sorry, there. Do you have it?
Yeah, thank you. How you going?
Good, thanks, Colin.
Why wouldn't they simply have the node there between B and C the same one as between D and E, so that B runs into that one and C comes up off it, instead of having that dummy line across there?
You'd need, okay, let's look at C. C is dependent upon the activity D and upon activity B. Now, what were you saying? Where would the line go?
Yeah, well, if that dummy line wasn't there, you'd simply be able to have that node between B and C the same one as between D and E, the same one. Just have it as one point. Wouldn't you be able to do that, so that A went up to that node and then B came back down to the one between D and E? So B came down to the bottom row there, and then C came back up straight up to the finish from that one between D and E.
You possibly could do that, yes. In this diagram, yes, you probably could do that.
Yeah,
okay.
I guess this
in this particular one, you probably could have done that.
Yeah, being a simple one, it probably could, but there might be circumstances in other ones that you need to have that dummy line.
Yeah. So you normally get dummy lines when there's more than one dependency. And that's what I wanted to just show on here. So if you've got more than one dependency, and you could have 3 or 4 dependencies, so you could have an activity that is dependent on 4 or 5 activities. Anyway, we shouldn't worry too much about this one because we're not going to use it too often. Most of the programming tools and the most of the, yes, I'm very happy that we don't have to. Most of the tools that we will be using, in fact, we'll be using the next one that we're going to look at, and that is the precedence diagramming method. And that one will use nodes. So it'll have arrows and then nodes. So the activities are in the nodes themselves, and then there's a precedence to those ones. So, and that's the way that most of the programming ones use. Microsoft projects certainly will use that one. All right, and there's another name for this that we're going to use just a little bit longer, but I don't want to use that just yet. All right. And the reason why I want to talk about precedence diagramming this way is because this has to be a team effort, right? Because if we do this on our own and we try and do these things on our own, we're going to get into a lot of trouble, right? Because one of the tools that we would use here is, in fact, the subject matter expert, right? If there are certain things that are going to be done, as we're going to rely on that. All right. Let me give an example. Can't think of a good one now. But I certainly don't know, for example, the curing time for concrete. I wouldn't know how long you'd have to wait or how much lag you'd have to put in. No, we're going to talk about lag just now. You would need for concreting, for example. I do remember one thing, and I was quite amazed about it. We had the concrete mixer come around and was putting down some foundations and some flooring for us. And they drove a 10-ton truck over it, and about 2 hours later, and I noticed that it actually didn't even move the concrete. So how it dried so quickly, I have no idea. I used to think it used to take about 10 days to cure. But that was quite amazing. In about 2 hours, that concrete had set. I don't know what they used to do it, and I don't know why, because I'm not in construction at all. But I wouldn't know those things. Your project team are going to be made up of subject matter experts that are going to actually help you say, well, you can't do this task or this activity until one of the other ones is done. And this is where Microsoft Project and some of the other ones are going to help us a lot. And most of them use precedence diagramming, or there's another word for it now, and I've forgotten what it's called. Let me see if I can get it quickly for you. What do they call it? That's it. Activity on node technique. So the technique is called activity on node. All right. So the node is the activity, and the arrows show the precedence. All right. So now on this diagram, there are a number of ways that we actually do it. The first one is finish to start. Right. Finish to start. Now that's the most common. Right. When you're diagramming something, you have an activity, then you wait, before you can start the next activity, there's a dependence on that one. That's why we call it a precedence diagramming method, because we look at it from the finished part and we look backwards. What is dependent upon what? So what activity is dependent upon the previous one? So the first one that we look at is the finish to start. But that's not the only way that we can actually have one. Right, there is another one which doesn't come in this diagram here, and that is finish to finish. Okay, you can start the activity at any time. Both of them can start at different times, but they have to finish at the same time. Right, so that way, when we're looking at precedence diagramming, there's a finish to finish. In other words, the diagram has to finish at the same time that the other one does. So that if you've got two activities, both of them should finish at the same time. That's called a finish to finish. Right? There is another one. There's actually 4 of them. There's another one, and that one is a start to start. That's when you run 2 or 3 or 4 activities in parallel. Now, there's some good reasons why you'd want to run them in parallel. Well, one of them would be that you save a lot of time if you're running them in parallel. You can run a whole lot of activities in parallel. It's certainly a lot more cost effective than running them in series, such as a finish to start, right? And then there is one more that's very, very rare. Okay, this is the rarest time, and you won't often use it, you won't see it. We just put it in here for completeness sake, and that is a start to finish. In other words, you have to finish an activity before you can start another one. Okay, so the finish of a later one has to happen before you can start the other one. So it's really a backwards one of a finish to start. Right? So the reason why that would be there is because there'd be other activities in this diagram that would force it to be where it is at, and then you'd have one that needed to start that you'd have to wait until the finish of this one before it started? Well, you see, that would negate the need for dummy activity lines. Yeah, absolutely on the other one. You won't get dummy activity lines on this method, Colin. You'd only get it on that previous method that I had where the activity is defined in the line. When the activity is defined in the node, you won't get those dummy activities. Okay, so on this one you won't see dummies activities. Now, the start to finish is a rather odd one, and it doesn't really make a lot of sense, and it'll only come up in certain instances. Right? All right, so that's where we are on these diagramming methods or mapping methods. All right, before we develop this mapping method a little bit further, who's heard of Pert? Raise your hands if you heard of Pert. Yes, Colin's heard of Pert. Colin's heard of Pert. Deborah, you've heard of Pert? Yeah, and Kim has heard of Pert. Okay. All right. We're going to look a little bit more at Pert when we do the duration estimation. And really, it's another complete way of actually estimating and adding to the diagramming. The reason why they don't call it Pert right up front here is because we've got to look at the duration and the estimation. Pert has got to do with duration and estimation. So we'll look at that in a little while. Before we do, however, we need to look at resource estimation. How do we allocate resources? How do we estimate those resources? Well, it's obvious now that we're going to look at these activity lists that we've got. We're going to look at the activity attributes again. And now we should have a resource calendar. What do you think we mean by a resource calendar? Well, that resource calendar is because there might be, in the calendar, there might be activities that can't start before particular dates. And with your network now, you're going to be able to start putting in particular dates. Right? So from your previous process that you did, you're going to have a resource calendar. So that's going to come into you. Now, the resource calendar is important because there's certain resources that will not be available, and it's going to have an impact. It's going to have an impact on your duration. Right? So let's just say that you have a contractor, and the contractor cannot start but before a particular date, and he's going to have that there. So it is an external constraint that says you can't start before this because the contractor can't start before that time. Okay, so the other thing that comes out of here is obviously a resource breakdown structure. Okay, and a resource breakdown structure is really like an organogram. All right, it's a temporary organogram, if you like. It's an organogram specifically for this project, not for the organization necessarily, but for the project. And the activity resource requirements. Okay, so that's where your calendar comes in. Deborah has asked a question. Let me just give you the microphone. There we go, Deborah. Get it? There we are. Okay, Deborah.
You there?
Yes.
Yeah, I just clicked it by mistake. Sorry.
No, it was. I clicked mine off by mistake. All right. Oh, you clicked that one by mistake. So you don't. All right. No, that's fine. That's fine. Actually, I might. There's so few of us on tonight. So let's leave that. What we have here with the activities in the resource requirements is when we've got to do a particular activity, the inputs to that would be resources, something that you'd need to do it. Another thing would be you might only be able to get, let's say one of your projects was to fulfill a particular contract, and in this one you had to do cold roll steel or something. Okay, so it was a very specific job for building a particular building, and you're going to build a lot of it, and you were going to use some cold roll steel, and you weren't able to get the steel in a particular time because you were going to have to wait for an overseas contract for some reason, and the supplier couldn't give it to you in a particular date. That would be a resource constraint, and we'd have to know that up front. So if you were going to build a building that required a particular amount of cold rolled steel and you couldn't get it because the supplier couldn't supply it to you until a particular time. So resources are going to have and that's why you would have an activity attribute lists, is because it would say, well, I need this resource for this activity, and it's not available until this date. So resource calendars and resource attribute lists, that's what we're talking about here. All right, now we get to the next one. And let's look at some of these tools and techniques when we do resource ones. The first one is expert judgment. Now, this takes me back a little while, but I can remember doing some of these things, and I used to do cable estimates for laying cables, and I can always remember one of the things that we needed was expert judgment in trenching. All right, and I remember as a young planner being taken out by the engineer and said one of the planners forgot to actually do pilot holes. And what happens when you go out for a contract is that the contractor is going to really cut on his price. Okay, he's going to cut on his price because he wants to get the job. But if the planner has forgotten to do pilot holes and he hasn't drilled along the route that he's going to have to trench to lay the pipes, and the contractor comes along and finds out that he has to use dynamite or something like that, you can be sure of one thing. You can be sure he's going to inflate his price. And you know what that's going to do to your project? It's going to blow your project out. All right, and that's exactly what happened on one of these projects. And he took us out to the site where he says, now would you have thought that they would have needed dynamite here? And he was quite right. If you look at it from the surface, that wasn't there. But if he had done his pilot holes and he had got some expert judgment on that and said, hey, you've got a problem underneath here, you're going to go down 3 foot and you're going to need dynamite, well, then you've got a problem. Okay, so it's always good to don't take things on the surface, but rather to get the expert judgment and to get the expert in to do the right things. So that can cause a problem. The other one is the alternative analysis, and this one always reminds me of another plan that I can remember that caused a problem on a job. I can remember someone not doing an analysis. They got to this dam and they had 3 ways to go with the dam. They could tunnel under the dam, they could go around the dam the one way or around the dam the other way. And not a good analysis was done on that one. When the contractor came to do this one, and he came up to the dam, he decided to go his own way. And he came up with a proposal. He said it was going to be a lot cheaper and than the way that he was, but actually it turned out a lot more expensive because the alternative wasn't actually programmed in there, or the analysis hadn't been really done properly. So alternative analysis is to look at and to check out each activity very carefully to make sure that there might not be an alternative way that appears to be cheaper. All right, let's go on to the next one. And another tool would be published estimating data. Now, I can only talk a little bit about this one on an area that I would actually know, and that's cables again. Now, let's just say that, what are we talking about here? There are tables from industry that would actually allow us to do this. In other words, if I had to lay a particular fiber core from somewhere to somewhere else, there are published estimating data on that. And there's no reason why we can't actually use that kind of estimating data. So it would say that if you are laying a cable of this diameter, it's going to cost you so much per meter to lay, or so much per 100 meters to lay. And that comes from history. All right, the industry collects the history from all the projects that it has, and it becomes quite a good estimating tool for us to actually use. So in our own area, we should be looking at that. I suppose in the construction industry, you would know how much it costs to build using particular material per meter, how much it would cost from a labor perspective, what the average cost of the resources are going to be in particular areas. All right, so published estimating data is something that actually we can use as a tool. Collins just said yes. Do you know of any published data that you've got, Colin? Are there ones in your industry? Okay. Yes, the building industry. So I'm pretty sure that there would be. There are specifications, etc. Yes, and so you would be able to get it from that. And for materials, yeah, I suppose you could. Yeah. All right. So that's one of the techniques. Another technique that we would use is bottom-up estimating. What's bottom-up estimating? Anybody has a guess of what bottom-up estimating is? Please help me. What is bottom-up estimating? Nobody's gonna try this one. All right. What happens when you come to an activity? Yes, Colin is working from smaller details up to the larger end. That's the right way of doing it. But what happens is you've come to an activity as a team, and then you realize, hey, I can't get a decent estimate out of here. So what you're going to do now is break it down further. Okay, so what you would do is you break it down further so that you can get more dependencies and you can get a better idea of what that activity is going to be. All right, so it's really coming to an activity in this part of the project. Maybe you should have a lot of your activities already broken down, and this is saying, well, we can't really get a good estimate here. Let's break it down further, and then we use the bottom up until we've got a reasonable one. That's all that they mean by that one. Now, the nice thing about some of the project tools, okay, is that a lot of if you're working in an organization that's got a lot of projects, you will find that they will have a database of a lot of these things, and that's part of the organizational. Remember I said the organizational assets? That would be an organizational asset, and you'll probably be able to get a project management template that will actually have a lot of that estimating done for you. So one of the final ones that I want to just say is that your project management software will be able to help you with that as well, especially in the estimating. All right, now let's go to the next one, which is the duration. And this is what I want to talk a little bit more here. And it is in planning. It's the last one in our planning activity. So it's the last thing in planning. And that is the activity duration estimation. Now, what are we going to take here? For the duration, to try and understand the duration of something, we need the activity lists and we need the resource requirements, the organizational process assets, okay, resource calendars, scope, baseline, and factors, and activity attributes, and all of those things. Now, this is where a resource calendar is very important. Okay, anybody used MS Project, you'll see that you can use multiple calendars. Okay, and you're going to be very careful about calendars, because this is where it becomes quite difficult to actually do that, especially if you're in construction, road construction or something like that, and you have a lot of wet days. What do we do to mitigate some of those risks? All right, so this is what we want to look at here. All right, so we're going to look at some ways of doing this. All right, now the one way to do it is to use Pert, right? All right, so this is where we start looking at Pert. But before we get to Pert, we're going to look at expert judgment again. All right, we're going to look at using an analogous estimating. What do you think that means? Anybody have a guess at that one? Analogous estimating. All right, that one actually means that you're going to take a previous project. All right, you're going to see what it was done in your previous project, and you're going to bring it over to this one, and you're going to say, well, that one had, you do this in recipes, right? Ladies like do this pretty regularly when they do it in baking. All right, or in food recipes, you would actually do that. All right, you would say, well, this one was made for 4 people. If I want to use 6, how am I going to do that? All right. I would have a calculation to do it. If I wanted to do it for 8, all I had to do was double up on the ingredients and double up on the time, probably. Not quite double up on the time if you're baking, right, or doing a menu or a recipe. But recipes are good ones for estimating. Now, you would do the same thing if you have done these projects before. So if this project had been done somewhere else and you have a template for it, you would actually utilize that. Contractors are very good people to actually bring into your team here to actually help with this one, because they've probably done it before and they can probably bring it in, and with a few calculations you would probably be able to estimate very accurately what your estimate is going to be. Now, parametric estimating. All right. In this one, what we're talking about here are using this. What we're going to be looking at here is really the relationship between historical data and variables. Now, let's take in construction, you'd probably use the area of square footage, and you'd calculate an estimate of an activity using parameters such as cost and budget and duration. All right. So this is where we're going to get. Let's just say we were laying cable, and we can lay 25 meters per hour. All right, so let's say we can lay 25 meters per hour, and if we wanted to, if we can lay 25 meters per hour, and the duration required to install the meters was 1,000, we had 1,000 meters to do, how long would it be? Obviously, it would be 40 hours. If you do 25 meters per hour, then that is called parametric estimating. Parametric estimating. All right, it's quite easy. It's 1,000 meters divided by 25 meters per hour. And there are quite a few of those models around. So if you wanted to do that, that's one way that you would actually do it. Right, the other one is the 3-point estimate, and that's where we get our Pert from. And let's look at the 3-point estimating. I would say to you that this is one of the things that you would use anyway in all your estimating. You're estimating anything. It's always good to get your most likely. How long is this going to be? So let's just say that you used any of the ones up there before. You used a parametric estimate, or you did something. Then I would say that that would be your most likely. Then what I would put in, okay, let's be optimistic here. If we were really optimistic on this duration, what would we put in there? All right, and that's the optimistic time. All right, and the other one, so we've got the most likely time, got the optimistic time, and now we know Queensland, and during this, August and November, we know we're going to get a lot of rain, so we're going to be very pessimistic, and we're going to say, well, we're going to have to increase this by so much, and that would be our pessimistic time. And then we're going to use Pert, right? Now, anybody remember what Pert means? Program evaluation and review technique. That's all Pert means. Program evaluation and review technique. And it uses this formula. All right. TE, which is your estimated time, and you've got your optimistic time, and you've got 4 times your most likely time, and then you add your pessimistic time, and then you've got your estimate. Why is it divided by 6? Get the average, yes. All right, if you've got the time, you've got your optimistic time, you've got your pessimistic time, and you've got 4 times your one, you've got 6 times. So we get the average. It's called a weighted average time, and that's what we use to estimate. Now, if you are using some software, it'll actually automatically do that for you. So I think Microsoft Project will do that for you as well. And so it'll ask you for your optimistic time, your most likely time, and the other one, it'll actually work out the average for you. Right, and there are some others that'll actually do that for you as well. So that it does it for everyone. So what would happen is that you would get an estimated time for each one of these tasks, and they're dependent upon one another. And we would then, because we've used the estimated times on this one, we would call it a Pert diagram. So a Pert diagram is the same as your PDM diagram or your unknowed activity diagram, and it means just exactly the same. So I just wanted to say that for you. That is what your Pert diagram is. So you have your dependencies, and what you want to get out of here is a task. Now, when we talk about schedule development, the ultimate goal is actually, in fact, to get what we would call the critical path. Okay, so we've used Pert to estimate all of our activities duration. We've used other things. We've used parametric. We've used analogous. Well, get it out tonight. And now what we want to do is to look at our schedule development. In the schedule development, actually what we really want to actually get out is the critical path. So I'm going to ask a question. Please help me out here. What we want to get out, if it's the critical path, the question that I want to ask, is the critical path the most important thing that you can do in a project is to keep your eye on the critical path? Is that the most important thing that you can do in your project? Can be. Okay. And I agree with Colin, it can be. I like his answer because the answer is actually yes and no. All right. Remember, as a project manager, the critical path is a tool. All right. Yes, you need to keep your eye on that critical path. That is going to tell you, the critical path is going to tell you how long the actual project is from start to finish, and each activity that is on that one. So you cannot have, if you haven't estimated your lead and lag times correctly on that one, that is the one that's going to give you the most risk. So in your schedule development, that is the path that is going to give you the most risk. That's what you need to keep on when you're planning it, to keep your eye on when you are actually planning it. This is the path that you need to watch very carefully and relook at how much buffering you've put in there is actually the answer that I'm going to actually put in there. In other words, can you put some areas in there to actually mitigate some of the risk of your critical path? The other ones are okay because you're going to have some leeway before the critical path changes. So let's look at developing that schedule now and getting out that critical path. There are the normal inputs, the baseline, the resource calendars, your activity lists again. This seems exactly the same, doesn't it? And but what you're going to come out with two things: your project schedule and your baseline. When you're finished with this, you're actually going to have the tool that you're going to measure in controlling. So in your time, from a time perspective, it is when you're finished with this activity, When you're finished with this process, if you like, you should have a project schedule and a baseline. A project schedule and a baseline. So let's look at what we need to do to get there and look at some of the tools. Now, I'm going to put these all up at once so we can actually have a look at it. Whoops, too many things. Let's look at the first one, your schedule network analysis. All right, you should have got a network by now. So you would have a look at that network. What you're going to look at that network is that you're going to look for the critical path. Now, the critical path is that path that there is no buffering. There is no one activity after the other one has to take place. There's no slack in that one. We're going to talk about, yeah, let's call it that way. There is no slack between any of the activities. Right? That's what we're trying to do, and that's why the network analysis is so important, and the network tools are so important for project management, because that is going to find your critical path. Now, what is the difference between a critical path method and a critical chain method? What's the difference between a critical path and a critical chain? I have to ask you these questions because these are the things that will come up there. You can't remember that term. Okay, the critical chain. Well, let's look at the critical path first. The critical path method calculates the theoretical early start and the finish dates, and the late start and the finish dates of all activities without regard for any resource limitations. All right? Then what you're going to do is you're going to calculate, and you're going to try and estimate, and you're going to mitigate some things by implementing some slack in there. All right? So you're going to put some slack in there because you know that something could actually happen. Rain could happen, an excessive rain. Someone could be late on one of the activities. And once you've scheduled that, and you've looked at the network analysis, and you've modified the project schedule, and to account for limited resources, then you're going to have what they call a critical chain. All right, so a resource-constrained critical path is known as a critical chain. Does that make sense? A resource-constrained critical path is known as a critical chain. All right, and how do we get there? Well, we're going to use, besides the network analysis, you're also going to use resource leveling. Now, that's where you love project management software, because that actually helps you with your resource leveling. What is resource leveling? Resource leveling is where you have overutilized resources and you need to spread them out. So you're going to do a couple of things when you're doing that. You're going to look at adding more resources to someone, and there's also going to be resources that are going to be slack. They're not going to be doing anything. They're going to be waiting for things. And that resource leveling says, well, where can I use some of those resources somewhere else? All right? So, to do resource leveling, where you've only got limited ones, what you're also going to try and do is you're going to do what you would call a what-if scenario analysis. So, you're going to say, well, if I add some things over here, what is it going to impact the project? And what you'll see is it's going to change your critical path. Does that make sense what I'm saying? Oh, it's so hard to put this across. I hope I'm coming across all right. If I'm going to actually do something just now, and I hope it's going to bring this result out. If I add 4 or 5 resources to something, I can reduce the duration time, right? So if I say that I have one activity that takes 40 man hours, and I put 4 people on there, it's now only going to take 10 man hours. Right? There's this particular term that we call for that. We call it crashing. Right? And if we want to compress an activity, then we will call it fast tracking. Right? So those are two terms that you need to remember. Crashing and fast tracking. Now, let me try and see if I can do this from here. Let's look at this. Let's look at this and try and work out a critical path for it. If we are given the following work breakdown structure, and we had to draw a Pert diagram on it, all right, the path that's listed below, we'd be able to identify what we call slack time or float time. This is time that we would be able to see or utilize to benefit and to mitigate some of the risks of the critical path. All right, so let's look at what the diagram would look like. All right, so it takes 2 days to install the shed. It takes 2 days to connect 2 days to connect up the utilities, and it takes 3 days to clean up the site. And then on the last day, we're going to get a handover of the keys. Now it says 1 day. That's because you're going to go and you're going to check up every single one of these. So here's a network analysis of what we're going to do on this one. All right. So here's our estimate. All right. So our ES, all right, is day 1, and our finish, our estimated finish is 2. All right. So there's 2 days there. All right. Then we're going to have a look at connecting the two. We could do it in parallel. All right. If we're going to do it in parallel, what do we got? At the top, we've got an estimated 3. Right, because that takes 3 days. So day 3, we would be able to start connecting utilities. But on day 3, we could also start. On the cleanup of the site. All right. So on day 4, we would finish utilities. Our critical path then is going to be the bottom one. Do you see that? All right. What can we do on the critical path to actually mitigate any risk that we have? All right, what we could do on cleaning up the things is we could add resources to it. All right, does that make sense? So let's look at what we would do here. All right. Our float time then would be on the connecting of the utilities. See, if we go through there, we start on our late time. So if we're looking at late, we have a late part there, and now you can actually see the critical path will actually change. All right, so if our late was on a late finish on that one, then it was on day 5, we had slack time on that one. Now we don't have slack time on it. All right, so I hope that's going to make sense, but you can ask questions in a minute. All right, so let's have a look at this. To install the shed in 2 days and hand over the keys, you've got 2 days here. You've got 3 days for the cleanup of the site and 1 day for the handover. All right, now if we wanted to build a Gantt chart of that, the final thing that we would do in scheduling is in fact to build a Gantt chart. It is the last thing that you'd want to do on that one. And what we would do here is actually say we'd have a task ID, which you would have done on those ones. There's your task. Now MS project and those project are always there. Now you'll see that there's a Saturday and Sunday, so what's going to happen is that it will go over that Saturday and Sunday. And there's a start to finish, and there's another start to finish. All right, so there we can actually see what is going to take until the last one. Here's the last one that's going to come up. All right, and that one is also the start to finish. Okay, so that is a Gantt chart. Now, hi Lance. Lance, we're just about finished on this one, and we're going to have question and answer in about a half an hour. I'm not sure whether you want to come into that one or whether you want to wait for that. I don't mind if you carry on now, but I think I don't sure how we got the times wrong there, Lance. Are you there? Can you speak? All right. The last part of tonight's one is looking at controlling the schedule. These are the same techniques that we're going to use that we did for planning it. Okay? We're only going to add performance reviews. Now, performance reviews look at what the performance is. Yes, thank you very much. Thank you, Graham. That's what happens when you rush, hey? Thank you, Graham. Then we do performance review. A performance review looks at what you've actually done, what you've accomplished with that one, and then you look at the variance between what your baseline said it should be and your actual. And the same goes for your variance analysis. Now that's where project management software really comes in. And then you can actually then go around and redo your resource leveling if you've had delays put in or lead and lag time, which I haven't actually talked about. Right, now's a good time to talk about lead and lag. All right, what is a lead? Can anybody give me what a lead is? During that control period, we might want to actually do refinements on this one and keep them up. Now, I've always said that one of the most important things within a project is, in fact, as you're going through there, if you can reduce the time because you can see something's taken, it's a very good practice to actually reduce the time early on in the project. It actually will leave you space if something happens later on in the project. So it's very important to actually look at trying to build up a buffer with a project management right in the beginning of your project. Some project managers leave it until the end, and then they find that they are really critical because some things have arisen that they didn't anticipate. So adjusting your lead and lag time even in the beginning while you're controlling the project is a very, very important thing. So let's just look at those two terms and look at what the technique of applying lead and lag to that. All right. So can anybody tell me what a lead time is? Time allowed. Thanks, Deborah. Time allowed. That we must wait before something can start is what Colin said. And Deborah, I agree with you. Allowed. That the time that takes. So a lag time. Can you tell me what a lag time is? Basically the other end. It's the time that we have to wait for after the task has begun before we can actually finish it. And that's normally, say, curing of concrete or something like that. All right, so before we can start on something else, we have to wait for that. Right. So time to wait after a task has begun. So that's the lead. So there's two other tools that we can actually do with that. And what we need to look at here is where there are lag times to try and see where we can overlap, and where there are lead times to see if we can't make other tasks actually fill in that gap. That way we actually reduce the one, especially when we're controlling it, and we've buffered in some type of things in there. We must be very careful not to do that. Some project managers like to put in a buffer for everything that they do. So what they do is that they say, well, it's going to estimate we're going to estimate that this project is going to take so long, and they actually add 50% to it. That is a very bad technique. Because Parkinson's law says that a job will take the time that you've actually allocated for it. Right? And one of the problems of doing that is that it's better to say I am going to buffer in and have a reserve buffer of a duration. In other words, say that don't put it into the task itself, but add time between the tasks to actually take and mitigate some of the risks of having one task on a critical path. All right. So do you understand what I mean by that? Okay. Graham says yes. All right. So what we're actually doing is that we're actually mitigating the risk of the critical path. All right. What we can do then, while we are in that one, is actually we can do schedule compression. So if we're running out of time, what we're going to do now is we're going to try and compress things. Okay, we've got it. All right. When we try and compress things, we're going to either put some resources onto it and increase the cost. And there's ways where we'll talk about. We're going to talk about that when we talk about the budget next week. How do we have a reserve of the budget? So what we're going to try and do is manage the two things, time and the budget. So we need time reserve, but we also need budget reserve. And between the two of them, we can look and see how we can best manage those two to make sure that we have the right deliverables in the end. Right? So it's always the adjustment of the time and on budget. So those are the two things that we can play with when we are budgeting and planning the project. So we must be careful that we do things accurately and then mitigate risks of these things. So that's why achieving the critical path is so important. And even when you are actually trying to control and execute the project, is to try upfront in your beginning of your project to try and save and compress your project so that you have more lead time at the end, more lead time or float time is another way of putting it, towards the end. Because that way you actually make sure that your project finishes on time. Now, that's all I have for you tonight. Are there any questions? Any questions tonight? Deb, you actually. Okay. Unfortunately, Deb, I was a bit late on that one, so they will be up by Friday, I'm afraid. So the topics for the assessment on this one and the assignments will be up by Friday. I'm sorry about that. Next week's one will be up on time as well, so I won't get it. Won't be late next time. Sorry about that, Deborah. Yes, I'm going to handle that one in the question and answer, and I will also email that one to you afterwards as well. Yeah. All right. So if I can see you in about 20 minutes, then we'll do some question and answer. Thank you very much.